In this video, I'm going to give you a brief introduction to Neural Tools. Neural Tools is another piece of software that's available in the Palisade Decision Tools suite, and it's one that we haven't used yet. In fact, it's one that I hadn't planned on using. But I'd like to introduce you to it because there have been a number of discussions in the last couple of courses that convinced me this might be a tool of some interest to some of you. So we're going to use an example here, and what you need to do is to get Neural Tools up and open, and it should look like this. There'll be a new tab that says Neural Tools, and there'll be some new icons, and this data set will be available to you. I would love to have a great construction example. I don't. So we're going to use this database here. And what this database is it's about 500 data points that describe automobile loans. So in column B, we have the status of the person. It's either a past applicant, and so we have some data, or it's a new applicant, and we'd like to know what their likelihood of paying the loan on time is. So we have some descriptors. We have the age of the applicant, their state, whether they rent or own a house, what their salary is, how much they intend to borrow, and then, at least for the past applicants, we have the outcome, whether they made timely payments, late payments, whether they defaulted, and that sort of thing. So your challenge is going to begin to think analogically here. So we're trying to predict how people will perform on automobile loans, and you might be trying to predict how a Tainer gate is going to perform, or how a lock pump will perform, or how a levy will perform. Now, presumably you would have lots of data on levies, and they would become your rows, or lots of data on lock pumps, or lots of data on any kind of investment that the Corps might become engaged with. And then you would identify variables that would be relevant for identifying the performance of the pumps or the levies or the Tainer gates or whatever it might be. So you might have age and result of last inspection, or evidence of metal fatigue, or whatever kinds of variables would be relevant to you. This could also be used, I think, for budgeting packages where the rows could be different budget packages. But let's get to the tools. So you've got some sort of database, and the first thing we have to do is define a Neural Tools data set. We do that by placing the cursor anywhere in the data set, then click on Dataset Manager. You will have the opportunity in here to name your data set. That's already been done. It will identify the Excel range, and you will have the opportunity to modify that if you like. You can check Apply Cell Formatting, and that'll give you the dotted lines and the blue heading and that sort of thing. So if you like that, that's useful as well. Down below we get the variables. The variables are identified by their Excel data range. The names are given by the table that you begin with. And over here we have a variable type. So you'll see that the variable B, this status, this isn't used in the analysis. We have several independent variables. Some of them are numeric, like age and salary and loan amount. Others are categorical, like state and housing. You need to have at least one dependent variable, and in this case that's the outcome. Notice that there are pull downs here so that you can identify the type of variable that you're dealing with. So once we've identified the database, we close this, and now what we're going to do is we're going to first train our data, then we're going to test it, and then we're going to make predictions. So to train the data, we're going to use the existing data that we have, and here's how this works. I click on Train, and up pops this window. The Train tab is selected first, and usually, at least when you're beginning to use this, you're pretty safe by using the default values, if you will. This says automatically test on randomly selected cases And this is telling me, when training is completed, we'll test on randomly selected cases. So we're asking the software to select 20% of these cases in here to run a test on. We're also asking it to automatically predict missing dependent variables. So for example, we have our new applicants. Here I just have one, but we might have 20 or 30 new applicants, and we're asking for a prediction on those. We're going to go to the net configuration. There are 3 ways to run this neural net. This is quite complicated, so you're going to use the default unless you have reason to do otherwise. The description's found here that you can read at your own leisure. Then the last tab is runtime. You don't know how long it's going to take to train your data set. So don't be frightened by the default here of 2 hours. It won't take that long. But if you have a very long data set, it can take some time. So ordinarily, you would want to use these defaults to make sure that you allow enough time. We're going to click on Next. I'm going to delete this because I did this in practice. So ordinarily, you won't see that particular dialog box. This is the dialog box that you want. It summarizes your training settings. It summarizes your variables. And what we're going to do here, you won't get these warnings because you will be doing it for the first time. So I'm saying, sure, go ahead and overwrite. But I'm going to hit train. And now what's going on is that was the training process. It can take a considerable amount of time in some circumstances, but I've chosen a database to make it kind of short and sweet. You're going to get a sensitivity dialog box here. You can do a sensitivity analysis, but that's going to be beyond the scope of our discussion or introduction. So I'm just going to say no to that because that can take some time. So what we get is the Neural Tools summary here. We get some basic information. It says the number of cases that it used for training was 400. Remember, it held 100 cases out for testing. The training time was very quick. There were relatively few trials. There were relatively few bad predictions. And so in the training, this is a summary of the training that we just went through. Here we get the number of cases. There were 100. The percent of bad predictions, we would like that to be similar to the training. It's pretty close. We might like it to be better, but that's that's what you get. What you get is what you get. So let's go down here and take a look at the classification matrix for training cases. So for training, it said of the defaults, 25 actual defaults were classified as defaults, and 2 were incorrectly classified as late payments. So in the training, we had a 7% bad performance on the default. For late payments, there were 65 late payments correctly identified, and 1 was incorrectly identified as timely. So there's a 1%. 1.5% bad rate there. For timely payments, it did much better. It correctly predicted 307 out of 307. So using 80% of the database and for training, this is a summary of the results of the training. Now we get to the testing. These are the 100 cases that were held out. So here we're seeing for defaults, this is where we had a little bit of a problem. It wasn't real good at predicting defaults. It correctly said 3 defaults were defaults, but it also said that 2 defaults were actually late payments, and they were not. When we look at the late payments, we see a little bit of an issue there. 11 late payments were correctly identified, but 4 late payments were incorrectly called timely. We see that we did a great job for timely payments. So if we were going to use this model to predict who's going to make timely payments and give loans to them, then the model's pretty good. Okay? Now, if I explain everything, it will take forever, but we have pictures histogram of the probability of incorrect categories for testing and for training and all that sort of thing. You can examine them at your leisure again if you want to do that, because I want to get back to our database here and I want to show you what happened. We have here our test data. So for example, this is a person who made late payments. We predicted based on the model that it made late payments. There was a 97% confidence in the prediction. There was some chance of a bad prediction, but this turned out to be good. Okay, so this new table that has been created shows the results of the testing. It shows you which rows were randomly selected. Here's one that we want to look at. Here's an example where an applicant actually defaulted, but our model predicts a late payment here. The confidence you see was relatively low, and this was a bad prediction. So you get the results of the test here. We can test again, and I'll say yes, overwrite, and we get a new set of results, and they can be different because they pick a different number. They pick different cases. So if you remember, we had default rates that were really pretty rough the last time. This time our prediction rates are better. So if I go back to our data set, you can see when we tested on everything, this is testing on all of our data, we got more comprehensive results here. So now we've trained our database, we've tested, and now it's time to predict. And what we want to know is what is going to be the case for this new applicant. So if you were using maintenance strategies where some sort of maintenance technique worked or didn't work, or budget packages, where budget packages were approved or not approved, or whatever it is that you're trying to predict, that's where we are right now. So this is the prediction part. I click on predict, and I'm going to live with all the defaults, and it says it's checking the prediction, and I'm saying yes, go ahead and predict. And it predicts for this person that this person right here will make timely payments. We see the prediction confidence is about 77%. So we're thinking that's probably a person that we want to lend money to, and we would go ahead and do that. I could add a number of applicants here. I could add their age, the state, whether they own or rent, what their salary is, and how much they want to borrow, and we could make predictions like this. So I don't know if this tool has any potential appeal, but I wanted you to at least know that it was available. If you've got questions, please ask, because I know that was a rather schizophrenic sort of introduction to the tool.